Hi everyone. In today's challenge, we are going to solve this problem. The problem name is path with maximum probability, and the problem number is 1514. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. And today, we are going to implement our logic in Python and C++ programming language. We are not going to implement with Java and the JavaScript just because the video length is going to be too long, right? But believe me, guys, if you understood the logic part and you have seen the implementation of Python and C++, then definitely you can also implement in your programming language as well, right? The syntax is going to be different, but rest of the thing is going to be same. So, guys, now let's see what this problem says, right? So, problem says you are given an undirected weighted graph of n nodes, zero indexes, represented by an edge list where edge of I is a of a comma b, right? So, simple thing, guys, we are given first of all a graph, right? In input we are nothing but we are given a graph first thing, right? And there the graph is represented by edges array where at each index we are going to have a comma b, means there is an edge between a to b, right? And this is an undirected edge, right? So we I have mentioned this directed, but this is an undirected edge connecting the nodes a and b with the probability of success of traversing that edge success probability 5. Simple, guys. They are also given one more thing which includes success probability, right? This array. So whenever we are traversing from a to b, then whatever the we can say the index at that particular a is going to be that success to traverse over that particular index, right? So let me tell you how. See, if we have this particular index, you can see in input 1, example 1, and input we have 0 comma 1, right? That means there is an edge between 0 to 1, right? So the success of this traversion is going to be nothing but 0.5, right? So we can say 0.5 is the success probability of traversing from 0 to 1, either from 0 to 1 or 0 or 1 to 0, right? So that is nothing but given with respect to this index, right? So 0 comma 1 present at 0 index, so the success probability of 0 index is going to be nothing but success probability, right? Fine. So this is thing clear. Now let's move to the next line, which is nothing but we can say given two nodes, starts and end. Find the path with the maximum probability of success to go from start to end and iterate success probability. So guys, now we are given two more inputs. So far we have seen that we are given four things, right? First thing is graph, which is nothing but edges array. Second thing is success probability. The third thing is nothing but we can say now start, and fourth thing is nothing but end, right? Now let's see the role of these all inputs. The first role is nothing but edges array is nothing but represent the graph. So this is going to be consisting of a comma b, right, like this, where a comma b represent that there is an edge between a to b, right? We can come from we can go from a to b. We can also go from b to a as well, right? So the success probability of this particular we can say that traversing is going to be nothing but represented in this success probability array, right? Let's say for this 0, this is 2, 0.2, right? Fine. Now after that we are given start, this is an integer. Let's say integer is 0 and end is, let's say, integer is 2. So which means nothing that, guys, we have to start from 0 node and we have to reach at the second node. But what now we have to do in this problem? We have to find the maximum probability. We have to find the maximum probability from starting from 0 and reaching to the 2 node, right? If there is no path from start to end, then return 0. Your answer will be accepted if it is different from the correct answer by at most 1 raised to power e minus 5, right? So that means 10 raised to minus 5. It is different by this particular thing. Then we can say our answer is acceptable. And if there is no path exit, that means we have to return 0. There is no probability of going from that particular given node to that whichever node, right? So these are the problems we can say statements. Now let's see the example. Then try to understand this particular problem statement. So what we have in the first example, let me remove this thing. Now guys, in first example we have 0 comma 1, 1 comma 2 and 0 comma 2, right? So you can see, guys, in we can see this particular image as well. We have an edge from 0 to 1, we have an edge from 1 to 2 as well, we have an edge 0 to 2 as well, right? So from 0 to 1 we have a probability of 0.5. From 1 to 2 we also have the probability of 0.5. From 0 to 2 we have a probability 0.2, right? I hope it makes sense. Now what we have to do, we have to start from 0 and we have to reach at the 2, right? Because end is equal to 2. So we have to reach here. Let me change the color. We have to start from this node, we have to reach at this node, right? But we have to find the maximum probability now. So how we can find? See, guys, probability always get multiplied if you have seen the conditional probability, right? This is a math concept, but just for now your understanding, just try to understand that if we are given two probability, then we have to just multiply it, right? So what we are going to do here, we are going to say 0, this is 0, right? So we can, the path exits, one path exits 0 to 1 and then 1 to 2, right? And the second path exits directly 0 to 2, right? There are two path exits. So if we consider this particular path, let me make a circle here, right? It will be a little confusing. So this is first node, this is second node, right? And this one, this path. Now guys, the probability from 0 to 1 is nothing but 0.5. The second probability is 1 to 2 is nothing but 0.5. The probability from 0 to 2 is nothing but 0.2, right? Now guys, think about this. Reaching from 0 to 2, here the probability get multiplied, so 0.5 into 0.5 is nothing but we can say to 0.25, right? And here is only 0.2. So which one having a maximum probability? We are having a 0.25, right? So we can say answer is nothing but 0.25. After that, 3 zeros, right? This is a, we can say in a floating. So I hope it makes sense, right? So we are going to return nothing but 0.25 because it is the maximum probability we are getting from starting from 0 node reaching at the second, right? The second example we are going to see here, guys. You can see we have given this particular graph, right? Now we are going to start. Let me remove this. Now we are going to start from 0. Again, we want to reach at 2, right? So if you will see here, the maximum probability again 0 to 1, 1 to 2, and directly 0 to 2. So this one is going to take 0.5. This is also 0.5. So totally 0.25. And here it's only going to single this path is going to take 0.3 probability. So which is greater than 0.25. So we are going to return nothing but 0.3 only, right? Which is the greater one. I hope it makes sense, right? The next example here you can see we are given this thing. So we have to reach from 0 to end to right. From this node we want to reach to this, but there is no path exist. So we are going to directly return 0, right? There is no path exist, so return 0. I hope it makes sense, right? So these are the examples. So we have now completely understood the problem statement, what we have to do, what are the inputs we are given with, and what we have to return, right? So now let's move to the logic part and see how we can solve this problem, right? What is the logic? How we can solve this problem by writing a code? So I have written here logic. Now guys, what we are going to do, the only thing which we are going to use is nothing but the first thing is, if you know what is structure algorithm, but forget about that as well. We are not going to mention here, otherwise you will get confused. We're just going to use here DFS, or we can say BFS, right? So BFS will be better here. So we are going to use a BFS, and we are going to use a priority queue, or you can say min heap. And why? We'll see later, right? So we are going to use a priority queue, min heap, or we can say BFS, right? So what we are going to do, we are going to always start from we can say this is start node, right? From 0 we are going to start, fine, and from 0 node we are going to reach to the all the neighbor nodes, and we are going to keep calculating the maximum difference we are maximum probability we are getting, right? So if we consider this first example, so guys, initially our priority queue, so let's write here priority queue. Let's understand this easily. So guys, in priority queue we have currently we're going to have nothing but we can say reaching to this node, we are starting from 0 node, right? So from we are standing currently standing at 0 node, so we are at 0, so reaching to the 0 node is nothing but probability 1, right? We can say probability 1, right? So we can say, I'm saying that currently we are at we can say at 0 node, so this index is going to tell nothing but 0, which node we are standing. This is 0 node, and the probability of that node is nothing but 1 only. I hope it making a sense, right? So we are at 0 node, the probability of 0 getting a 0 node is 1, right? After that, now we have this in our priority queue. Now what we are going to do, we are going to say pop out this one, right? So we are going to say tell the minimum one from this priority queue. So initially we have only one, so it's going to return out this only, right? So from this 0 node, now we are going to check how many nodes we can traverse, right? So remove all these things. So guys, you can see from 0 we can either go to 1 or 2, right? We can 0, we can either go to 1 or 2, right? So first of all, let's check with 1, right? So I am checking with 1, so we can say the 1, right? So here I'm going to say first of all check the this success probability for this one from this path is nothing but 0.5, right? So you can see 0 to 1 there is a success probability 0.5, right? Try to understand here, this is a code part of the logic. And if we already have better, we can say maximum probability from any other path, so don't take this path, otherwise take this, right? So we have to maintain one more thing, which is nothing but array, right? Distance array, or we can say probability array, right? So let's write here probability array, right? What this array will do, this will array will calculate for 0 indexes, 1 indexes, and 2 indexes the maximum probability. So far we have got, so far we have 0 0 0, right? For this 0 we have 1, right? So we can write 1 also, right? For this 0 we have 1, otherwise for everyone we have a 0 0 currently, right? So what now we are going to do, we are going to say fine, we have 0 0. Now as we know that from 0 we can go to 1, first of all check what is the probability, we can say probability array of what is the probability of this one node. So you can see on the first index we have 0, right? So we can say we have currently 0 here. And what is the probability of this path? This is 0.5, right? So we can say all right, so this is greater than our 0, so take this particular one, right? So now we are going to say take this particular and update this. So we are going to say from 0 it's going to update by 0.5, and here we are going to say insert in our priority queue. So 1 comma 0 is going to remove, and here we are going to insert nothing but we can say this we reach to the 1 index, and the probability is nothing but 0.5. I hope it makes sense, right? Okay, now this is one thing. Now from 0 we can also reach to 2, right? From 0 we can also reach to 2, and here you can see we can say that we reach to 2, and here because 0.2 was greater than 0, so we are going to update this 0.2, and we are going to say here also 0.2, right? Now our priority queue is going to have nothing but 0.5 comma 1, 0.2 comma 2, means now we are at one index and two second index with the probability, right? I hope it makes sense, right? Now you can see guys, we also got the probability at second index, right? So far we have got the probability at second index, which means nothing but 0.2 only, right? So this is the one possibilities, but this is not the maximum one, right? So we could not return it, right? So we have updated our distance probability array by this like 0, this was 1, this was 0.5, 0.2, right? This was the probability array, right? But we have got we can say the probability at the second node, right? But this is not the maximum one, so we have to keep traversing, right? So take out again the minimum from the priority queue. So if we take a minimum from this priority queue, so we are going to say which is the minimum, 0.5 or 0.2. So 0.2 is the minimum one, right? So we take out this minimum. Now we are going to check it. Fine, we have taken the minimum. Now we are going to check it from 2, where we can move. We can move to 0, right? We can move to 1 as well, right? From 2 we can move to this direction. But see guys, if we are going to do this, so we are going to say we are moving to, let's say, 0, right? So from 2 we are again we are came from 0 only, we are again moved to the 0. So this will either we can stop it by maintaining an array, is wasted array, but we will not do this because we are using a one condition. If the probability of this particular path, which is nothing but 0.2, right? So 0.2 multiply by the previous probability was 0.2 only. So 0.2 is 0.2 is nothing but 0.4. So we can say if 0.4 is greater than, if it is greater than, right? If this 0.4 we can say greater than our this probability, zero probability, which was nothing but 1 only, right? So it will never be greater than, right? It will always be less than that. I hope it making a sense, right? And this is not 0.4, this is 0.04, right? 0.2 into 0.2, 0. So this will always be less than, so we'll not anyway we will not move to the same we can say path again and again, right? So this will never happen. Zero, this two will only gonna see this particular path, which is nothing but 2 to 1, right? So we can say okay, now we are moving to the one index. So from this 2 we are moving to the one index. So here you can see the distance array on at one index is nothing but 0.5, right? And we have it should be like less than, or we can say like this path is going to have 0.5 into the previous path is 0.2. If it is greater than, if this path is greater than the, already we have calculated the probability at this particular in the node which is nothing but 0.5, then only you have to consider this path. But here also if you will focus, this is nothing but 0.1, which is not greater than 0.5. So we are going to say nothing but fine, this is also not going to take, right? So from 0.2 this particular we can say data, we are not going to move anywhere, right? So we can say remove this one but not insert anything, right? Fine. Now we are going to take out the minimum, which is nothing but this one. We can say this particular numbers. So we can say now we have this practical. So take out the minimum from this practical, which is going to be nothing but only one element is there. So this is nothing but 0.5.1. Fine. From one where we can move, to either from one we can move to 0, we can move to 2. But we came from 0 only, so it will never be moved there, right? Condition will always fail. But from one we can move to 2, right? So for 2 you can see guys, from 2 we can say take out the first of all we can say this distance path, which is nothing but 0.5, multiply with the previous path, which is nothing but you can see 0.5 in the data. 0.5 is it greater than our the already calculated at the second index? Earlier we have calculated 0.2, right? So 0.5, 0.5 into 0.5 is nothing but 0.25. Yes, it is greater than 0.2, right? So we can see yes, it is greater than 0.2. So now update this updated value 0.25 at the second node. So we are going to say update this value. Now it should be we can say 0.25 now, and insert this particular thing in our practical, right? So we are going to insert this on our practical. So from 0.25, so we are going to insert this particular thing. So we can say now remove this one as well, so because we have pop out. Now insert nothing but we can say at second index the probability is nothing but 0.25, right? Again we are going to take a minimum from this practical. So if we take a minimum from this practical, so this is the only element which again going to pop out, right? 0.25 and 2. Now we are going to check from 2 where we can move to 0 and 1 as well, right? But this we have already come from there, so we can't move anywhere now, right? From we can move to 0 as well, but it will always condition gonna false. We can not move to 1 as well, the condition will always gonna false. So we can say here also it gonna not move anywhere. So we have already powered this one. So but it not gonna insert anything, so our practical will become now empty, right? Now if it is empty, so we are gonna break our we can say while loop, and here now we are going to return nothing but the data which is present in this array at the given end index. So end was 2, so we are going to find the data at the second index, which is nothing but 0.25. We are going to return nothing but 0.25. So finally guys, I hope you understood the logic. If you could not get this, so you can try this video at 0.5 we can say x or 0.75x speed, right? so you can have a better understanding. But yeah, this was the logic, guys. We are just going to use a priority queue, and we're going to keep getting the minimum value which have a minimum probability, we can say maximum probability, not minimum, maximum probability, right? So really sorry if I have missed something, but we are going to have get the maximum one, right? So we are going to get the maximum probability every time. So 0.5 was the maximum, so we have to use a max priority queue here, right? Not min, we are going to use a max priority queue, which you're going to have. You can use a min as well, but max priority queue will be better, right? So which should be the case, right? So we are going to use a max priority queue here, and we are going to solve this particular problem, right? So just the only thing we have changed here, earlier we were getting a minimum, we can say data from our priority. We have to take first of all the max data. Rest of the condition is going to remain same, right? So now let's move to the implementation part, and let's see how we can implement this, right? So I'm here. So guys, again I'm saying that if you use a min priority, then also it's gonna work, right? But here we are gonna use a max priority, right? So what I'm gonna do, I'm gonna say find first of all I'm with the Python. So first of all, what I'm gonna do, I'm gonna say create adjacent list. Adjacent list is gonna be nothing but empty dictionary, and on each I index we are gonna say create an empty list for I in range of this n, right? After that we are gonna say for we can say I comma a comma b in this enumerate edges. Here we are going to say find, you can say adjacent list of a dot append, we can say tuple of b comma p, right? So not p, we can say p is going to be nothing but success probability, right? Success probability of this particular I, right? And we can do like this, right? Fine. And also we have to do like for as this is a, we can say a direction, no direction and unit actions, right? So we can not unit action, it is not a action, right? So we can say, now we can say b dot append, here we can say a comma success probability of I, right? So this means that we can also go from a to b, and we can also go from b to a, right? Now once this is done, we are going to say now creates a heap in priority queue. So it is initially empty, and we can say heap queue dot heap push, we are going to push in this heap what tuple of -1 comma start. -1, why we are putting a 1 only, but -1 just because in Python we don't have a max heap, we are using a min heap just by multiplying it by -1, right? Fine. Now we are going to say distance array. Distance array is initially nothing but we are going to say 0 for all, right? So for all we can say nums, not nums n, right? After that we are going to say use a while loop, while until and unless heap is present. So you have to take a data from heap, so it's gonna give a data, so which we can say a node comma distance, not distance, we can say probability. Currently probability is gonna be nothing but heap q dot heap o, and let me write a spelling heap o, and here we can pass our heap, right? So once it give a data, we are going to check it first of all if this probability into the probability of we can say already we have at this path, which is nothing but tell our success probability. So first of all, let tell over all the child sets for all child, and we can say in our, we can say adjacent list of this particular node, we can say fine, this is our child. So this is not a node, this is a node, and this is our, right, probability, right? You can see firstly we are inserting a probability, then we are inserting a start, means a node, right? Now for child in adjacent list of nodes, so on each childs we are going to have two things. First is the child in nodes, and the second is child probability, right? So child probability is nothing but the, we can say success probability for that path, right? So we can say child node is going to be nothing but child uh, child of 0, right? Child of 0, and child probability is nothing but child of 1, right? Now we're going to say if child probability into our this current probability, right? Probability. So now if this is the greater than already the distance of this child node, then we are going to say fine, we have to update this. So we are going to say this is the case, so distance of child node is going to be nothing but child probability into probability, right? After that we are going to say insert in our heap as well, right? So heap q dot heap push, in this heap we are going to insert nothing but we can say child, not like this, we are going to say nothing but we can say distance minus, right? We have to do distance, and here we have to pass child node, and here we have to pass child node, right? And here we have to, whenever we are taking this, we are going to say our probability is going to be nothing but we can say minus of probability, right? Fine. Now let's run this code, and here we are going to first of all return this distance of, and let's see whether it's working fine or not, right? So I hope guys it should work. We haven't done any mistakes so far, I think. You can see guys all the test case passed, so let's try to submit this code, right? I hope it will also get submitted. So guys, here we are using a mini heap only, but we are passing a value with the -1. which converting our minimum value to a maximum value, right? Fine. Now let's move to the next programming language, which is nothing but we can say C++. So let's here go, and here first of all, what we are going to define? We are going to define first of all adjacent list. So we are going to say what happened to it. We are going to say first of all adjacent list. So it's going to be vector of pair, int, and double, right? And here this is for this for this, and here we can say give a name adjacent list, right? So let me give a name adjacent list, and the size by default is going to be nothing but n, right? Now we are going to traverse over each index for int I0, let me write 0 I less than n. What happening I plus plus, here we can say int our a is going to be nothing but edges of I and 0. Fine, int b is going to be nothing but edges of, let me write edges, and here we can say, let me give a better syntax, and here we could say I of 1, and here probability is going to be nothing but double of probability, success probability. So success probability, and here we can say I, right? Now once this is done, we are going to say adjacent list of that particular index dot push back. What you are going to push? You are going to push nothing but up, we can say vector, right? So in this push back, we are going to push a vectors. In this vector as well, we are going to push a pair, we can say pair, right? So here the first thing is in that integer, then the second is we can say this particular thing, right? Success probability. After that, same thing we are going to do for next line, and here we are going to say this one will become a, this one will become b, because this is not a directional one, right? After this, once this is done, we are going to come out from this loop. We are going to say let's create a heap, min heap. So we are going to say priority q, right? And this priority is going to take a pair, and here it's going to take int, then it's going to take double. So we have to give a first double, right? Fine, and then we have to give integer, right? Fine. Now once this is done, what we are going to do? We are going to give a name. This name is nothing but, let's say, heap, right? After that, we are going to say heap dot push. So what you are going to push? You are going to push a pair which a double is nothing but 1, and here the integer is going to be nothing but start, right? Fine. Now once this is done, what we are going to do? We are going to now start. First of all, let's create a distance array. So we can say vector of double, and we are going to say give a name distance, and by default size n, and by default value 0.0, right? Now guys, once this is done, now what we are going to do? We are going to say now use a while node, because node priority q node, that means heap dot is empty, right? Or empty. So if it is not empty, so keep traversing. First of all, pop auto data, right? So auto data is going to be nothing but we can say heap dot top. First of all, take a top, then you have to remove it, right? Heap dot top, right? Fine. Now once this is done, first of all, think about this. We are using a double, right, at first. That means by default this priority will take a max heap in a C++. In Python by default that take a min heap, right? So here by default it take max heap. So that's cool. So we are passing a data type pair double of in. So it's gonna pop out that. So now you can see guys, the first thing int our node is gonna be nothing but data of second, right? Int probability is nothing but we can say data of first, right? Now we can say for all the childs, for we can say all the pairs, right? So for auto data we can do for auto data in our adjacent list, we can say adjacent list of this particular node, right? So we can say reach to the nodes. Now here we can say int our child node. So let's give it a name as well, child. So for child, int child is gonna be nothing. What it gonna be? It's gonna be we can say child node. Let me write child node, right? Child node is gonna be nothing but child dot first, right? And here int not int, we can say double success probability, right? So success probability is gonna be nothing but, or we can say child probability child dot second, right? Once this is done, we are going to check it if child dot we can say child probability, right? Child probability into our probability is this thing is greater than distance of our this particular child node, right? If it is the same case, then what we are going to update our distance of child node is going to be nothing but we can say uh, this multiplier child probability into probability, right? Fine. If this is the case, now what we are going to do, we are going to say fine, if we have updated it, we have to put in our queue as well, with priority queue. So we can say heap dot push, we are going to push nothing but this child distance of child node at the first distance of child node, and then you are going to push child node, right? Child node. Fine. Now we are going to come at the this while loop, and we are going to say return distance of this n, right? So let's run this code and see whether it's working fine or not, right? So I hope guys it should work, right? but no, it's giving an error. It's giving an integer overflow. So here we have done a mistake, guys. Let's check that as well. So it's giving a, we're starting something, we are accessing something which is not possible, right? So let's see distance of child node, right? So child node is always going to be data node first, right? So this is adjacent list. So this is adjacent list, and in adjacent list we are going to having a data as a pair, right? So pair of int and double. So first thing is always going to be integer, second thing is always going to be double, right? So that will be nothing but child probability. Okay, not child, because success probability, right? And the for that probability, okay, so that is going to be double, right? Fine, let's run this code, see whether it's working fine or not. But again it's giving this. So double probability is nothing but data dot first and data dot first is always going to be double, and data dot second always going to be this, right? Fine, that is also working fine. And so we have done something wrong, I guess. Let's try to see where we are accessing it, right? So we are accessing over here only, right? So we are just accessing this thing. So if I just comment this thing, right, and we can say let's run this code. Let's see whether it's fine or not. So there's problem in not in this, there's a problem in this, right? Nodes. So if I just comment out this particular loop, currently I'm just debugging this, guys. I really feel very bad for this. This should not waste our time, right? Okay, if it is working fine, no, it's still giving an error. That means the problem is not there. So the problem is where? So problem is in here, guys. So let's check this as well. So if we try to do these things, right? Let's see. So right, so problem was here only. We are doing something wrong over here, right? So even do I do these things, right? Even do I do these things, so this is gonna give an error. So this is how I debug. So you guys can see that everything is working fine, just accept these things. So here we are accessing something which is not valid, right? So we have done these things. So we are doing a pair. We are saying that push back this p, this p, right? So push back this pair, and each is gonna have a vector, right? So fine, this is also cool, right? So at we can say vector of pair. So in each vector we are going to have a one vector of pair int and double, and we are accessing these things, right? So if we don't do this, and if we try to do this now, so still we are getting, so we are doing something wrong here. Success probability of I, and I of 0 and I of 1, right? Okay, so something is wrong over here in this line only, right? Still not in this case, we can say cool. How can I check this thing? I'm gonna say what is p now, right? So it's working fine now. So this is the only thing, success probability. This is nothing but, now this is also not the case, so we can say fine. Now let's do this. Let's do this now. This is so irritable, guys, so irritable. So nothing but we have seen this, nothing but the issue is here only. So we are, what we are doing, guys, we are saying the edges of I of 0, right? So this is edges vector of, we can say vectors. So on this index we are having this particular 0 index, right? So we always show that we are having this, but they are saying that this should not be the possible, right? So let's check this particular thing as well. So we are having this 0 1 1 2 and 0 2, right? So we are sure that this is going to have these things. So we are going to say int a is going to be I of 0, I of 0. This index of 0 is going to be nothing but this index is, so it should work, right? So it's giving us an error. Let's run this code now, right? So just give me a second. Okay, fine. And here we are going to see these things. And here, guys, you can see we have done. So the last thing which we are going to see, try one thing is that we're using it here n. So let's give it a size, right? So there is no possibilities, right? Edges for size, right? So let's do this. So guys, you can see that all the rest is passed. So just I check these things. That means the possibility is here. You can see, guys, here it is not necessary that we are going to have the same size of length, right? So this is the only case. Let's try to submit this code as well. So with this, we are going to successfully submit it with a Python, C++ as well, right? So as you can see, guys, it successfully got submitted. So we have successfully implemented Python, C++, and also we have seen the logic part, understanding part. I could not implement with the JavaScript and Java in this video just because the video is going to be really too long, right? But I believe, guys, you can easily implement now, right, in Java or JavaScript language. So that's all in this video. If you learned something in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.